With the beginning of May came the beginning of storm season in northeast Florida. That doesn't mean that it storms every single day here, but that conditions are generally in place often enough to see consistent thunderstorms. This increase in rain and thunderstorm activity is largely in part due to the sea breeze. Today we will be learning about the Florida sea breeze. We'll discuss what it is, what causes it, how it affects thunderstorms, and look at some real-life examples of how the sea breeze impacts storm development. Let's get into it. For starters, what is a sea breeze? A sea breeze is a localized area of cooler air that occurs near the coastline due to unequal heating between the land and the sea. It acts similarly to a cold front, separating warm and relatively cooler air. However, this plays out on a much smaller scale than a full-on frontal system. This boundary can be a driver of thunderstorm development and can enhance the strength of pre-existing thunderstorms. Sea breezes occur most commonly on the ocean, but can also occur along other large bodies of water, such as rivers and lakes. Now that we know what a sea breeze is, what causes it? As I mentioned a moment ago, a sea breeze results from uneven heating between the land and the sea. As the sun warms the planet, it warms the surface at around the same rate. However, due to water's transparency in the depths of the ocean, it's able to hold on to and absorb much more heat energy than the land can. The sun's rays have trouble penetrating the thick outer crust of the earth, resulting in much of the heat radiating back up into the air immediately off the ground. As the land continues to heat throughout the day, the air becomes more buoyant and has the ability to rise. This happens with or without the sea breeze occurring. However, when the sea breeze is around, it can act as a lifting mechanism. Cold air is denser and heavier than warm air, so the sea breeze presses inwards. It slides under the warm land air. This undercutting of warm, buoyant air causes it to rise further into the atmosphere, which leads to the formation of clouds, rain, and even thunderstorms. If you would like to know more about the sea breeze, I will include some more educational material in the description. But for the sake of this video, the last two paragraphs are all you need to know in regards to how and why the sea breeze forms. So now that we understand what the sea breeze is and why it forms, let's look into how it can impact the development of thunderstorms. As I mentioned in the intro, the beginning of May began to bring with it near-daily sea breezes. While there is no set date where this starts to occur, it usually begins sometime in late April or early May and really ramps up during the summer months. Really, whenever the temperatures start getting consistently hot, which is around low to mid 80s daily, beginning to reach into the 90s, that's when we expect to start seeing the sea breezes push inland during the daytime hours. This can lead to streaks of days where thunderstorms occur, typically around the noon to 3 p.m. time frame. Storms can also occur in numerous rounds depending on your location and where the sea breezes collide. On a typical summer day, the sea breezes will spawn thunderstorms in two primary ways. First off, scattered to numerous showers and thunderstorms may spawn as a result of one sea breeze passing over the land. The strength of these storms will vary due to a variety of factors, but they tend to be relatively brief, pulse-type convection, meaning that they flare up rather quickly, cause torrential rainfall with some lightning where they form, and then fade away within a short period of time. These storms are less likely to be severe. The second, often more dramatic way the sea breeze forms thunderstorms is when they collide. The sea breezes collide in different parts of the state depending on the day, and most often that is due to the flow of the atmosphere or the general wind direction. For example, if the wind is coming out of the southeast for the day, we would expect the Atlantic sea breeze to make more progress and push further towards the west coast, where the Gulf Coast sea breeze would likely be pinned to the land. The breeze might not make it very far inland at all, maybe only a few miles, or it could be confined to just near the coastline. And in turn, if there's not enough forcing, the Atlantic sea breeze might not be able to make it across the whole peninsula to make impact with the Gulf Coast sea breeze. But the first type of thunderstorms I mentioned in the last paragraph might still have spawned as a result of the Atlantic sea breeze. Under ideal conditions, both sea breezes will collide at some point over the state of Florida. This most often happens towards the middle of the state, but as previously mentioned, this zone can shift day by day. The collision of the two sea breezes causes much of the same forcing that one sea breeze causes, just to a stronger effect. Storms that spawn over or around this field of converging winds are often very explosive. The breeze can also temporarily enhance pre-existing thunderstorms that have already formed prior to the passing of the sea breeze. In our area, this happens fairly often in the summer months. Storms that form off of the Gulf Coast sea breeze can sometimes move faster than the breeze itself, outpacing the frontal boundary. If they continue to maintain their strength, they can gain a boost from the approaching Atlantic sea breeze. Now we're going to take a look at a recent example of the sea breeze enhancing a local thunderstorm. We start on the extremely warm afternoon of May 5th, 2024 at around 1 p.m. The Atlantic sea breeze is beginning to push its way inland. On radar, the sea breeze presents itself as a thin blue line, which the radar interprets as light precipitation. Likely this is a collection of bugs, dust, and other small particles in the atmosphere. There is no rain with the initial passing of the sea breeze. That comes with the showers and thunderstorms that develop in its wake. The Atlantic sea breeze was rather slow moving that day, taking around 2 hours to get from Interstate 95 to the St. Johns River, which is a distance of around 10 miles, give or take. In its wake, a few heavy downpours did form, but these cells did not produce lightning. These cells spawned between 2 p.m. to 3:30 p.m., but none of them lasted very long. By 4 p.m., the breeze was heading towards western Clay County after picking up a bit of speed, where a group of loosely organized showers were moving to the southeast. As the sea breeze passed over our area, a heavy downpour would form just to the west of Middleburg. I was able to get footage of this developing cell, but it surprisingly did not move over us. As you may have noticed, many of the storms that formed on this day did not move very much from their point of origin. At around 4:40 p.m., we noticed a storm to our southwest was beginning to pick up some steam, so we decided we were going to go after it. Zooming in on the cell in southwestern Clay County, a very interesting feature is noticed towards the 5 p.m. hour. What was left of the mini frontal boundary caused by the advancing Atlantic sea breeze gets ingested into this thunderstorm. This cell was the only thunderstorm in our area at the time and was putting off a few lightning strikes, but after taking in the sea breeze, it began to strengthen quite rapidly. Switching over to the echo tops, we could see that complex looked rather unimpressive before 5 p.m., but once the sea breeze passes under the storm, a surge in cloud tops can be seen. At its peak, the storm reached cloud tops of over 47,000 feet. This increase in height helped lead to development of a few more lightning strikes and overall intensified the storm for a brief period of time. By this time, we were beginning to approach the thunderstorm and started recording footage of the drive. While we did not see any lightning directly, the storm did bring torrential rainfall with it. Let's see what one of these sea breeze storms can do.
Exploring pretty far south into southwestern Clay County, chasing some of our first sea breeze thunderstorms of the season here on May 5th, 2024. Not the most impressive cell ever, but it did have some pretty decent cloud tops earlier. And just trying to explore a little more. Smoke or fog ahead. Oh. Got some actual hills? Real? Damn. I guess it isn't this flat after all.
You believe it. And there are hills in our local area.
So real. I mean, I'm not giant or anything, but like,
There are hills.
that's
There's another one up ahead. Oh my god.
wow. that's,
3 in a row?
that's more vertical diversity over here than we get in our county. Or
smaller than
back
last
towards
one.
home. As you do start to head a little further west into Clay County and the rest of like the more like central panhandle counties, it does get a little taller. There's a little more variance in terrain. It's not a lot. I think it only goes up like 400 feet off sea level, but I think at home it's like 35 feet off sea level.
Oh.
Really, dude? Yeah. Go ahead. Go.
Yep.
I'm not speeding in the rain. No, thank you. I'd say, looking at the radar, we're getting pretty close. The core looks like it's actually over like Keystone itself right now. It seems we're a few miles outside of Keystone still.
Getting up strong now.
Yeah. I still think we're relatively towards. Look, you can see the sun actually. But it's still not really heavy sun shower then. Oh, look, it's coming out.
That's crazy.
Yeah, there you go. That could mean that the upper levels of like the storm are starting to break down a little bit though.
Yeah.
Because I would assume if we're this close to like getting towards the core, it should probably be pretty dark.
Yeah, I don't know. It's getting brighter.
The rain's getting heavier though.
Yeah. Probably slow it down.
Damn, they make y'all pay $3.78 for gas out here? That is not okay.
The sun's starting to hide back.
Yeah. It looks like it's starting to get a little heavier up ahead again.
Yeah.
We're almost to Keystone now.
Yeah.
I figure we'll probably stop once we actually get in there. It's already down more. Yeah, I think we're getting a chunk of it. It looks like there's another cell of it starting to develop a little towards our west. I'll take a look at that. Nice. Somewhere. I mean, I don't think we're going any further than Keystone. But down into the swamplands.
Apparently Tennessee made trucks like that illegal.
Those lifted ones?
Where they lift at the front, yeah.
Let's find a place to park. Alright. Finally got down to Keystone. Storm's not really looking all too impressive anymore in terms of the lightning and its structure, but it is still bringing some very heavy rain. Oh, there's some thunder at least, eh? So yeah, we might just sit for a few minutes and enjoy the cool air, because it was like 94 degrees today at home, and now it's only like 70 here, so I might just chill here for a few minutes before we head home.
Admittedly, that was not the most dramatic showing of what a sea breeze thunderstorm can do, but I think you get the picture. Localized, heavy downpours where the main threats are heavy rain and cloud-to-ground lightning. These storms can actually be very beneficial to us during the summertime months, providing a nice temporary relief from the heat. Throughout the rest of the evening, a few more showers and storms would pop up around North Florida, but nothing very notable. For the last section of this video, I would like to briefly discuss a few more examples of times where the sea breeze enhanced the thunderstorm, but these will be a bit more impressive than what I just showed you a moment ago. On May 15, 2022, a setup very similar to our recent stormy days was unfolding. There was a general risk of severe thunderstorms with no severe weather expected. However, Mother Nature had other plans. Thunderstorms began to rapidly bubble up around the First Coast region starting as early as noon. As these singular storm cells began to drift around, they would merge over the Jacksonville area around 1:30. Along with these storms, the Atlantic sea breeze was beginning to push further inland as well. The storm seems to intensify greatly as the sea breeze moves into the opposing storms to the west. At 1:44 p.m., a National Weather Service meteorologist reported a drill bit-shaped tornado touching down in Jacksonville. Fortunately, the tornado was extremely short-lived and did not cause any substantial damage. This tornado went completely unwarned, with the warning not being issued until well after the tornado dissipated. If you would like to know more about this tornado, I have a video on this storm, so check that out if you're interested. Tornadoes spinning up off the sea breeze is not as uncommon as you may think. Using this resource from National Weather Service Tampa Bay, I found numerous examples of thunderstorms developing tornadoes after spawning from the sea breeze, or even as a direct result of the sea breeze. Two notable examples to me are this one from June of 2008, where a tornadic supercell took advantage of the Gulf Coast sea breeze in order to produce a tornado. Unfortunately, RadarScope doesn't want to load radar data from 2008, and Fort Myers is also dozens of miles from the nearest radar site anyway, so you probably would not be able to see the sea breeze. However, I can show you very clear radar data for this EF0 tornado that spawned in Tampa back in May of 2009. As you can see on the reflectivity, the numerous outflow boundaries along with the two sea breezes make for quite the messy storm mode. This tornado was deeply embedded within a torrential downpour, and nobody was able to see it. That is another concerning part about tornadoes that spawn from these sea breeze storms. These cells often contain very high amounts of precipitation, which combined with their fast spawning nature, can make them extremely dangerous under the right conditions. And that's all I have to tell y'all about the Florida sea breeze and how it can influence thunderstorms. If you enjoyed this video, please leave a like and subscribe, it really helps us out, and it lets us know that you enjoy what we create. I had a ton of fun making this video, as the sea breeze is one of my favorite topics when it comes to Florida weather. So, hope y'all have a good day, and we'll see you in the next one.